So today we are going to discuss covalent bond. In previous class we discussed about ionic bond. Then now we are going to discuss covalent bond. So which is nothing but a Lewis-Langmuir theory we have to discuss now. Lewis-Langmuir theory. Okay. According to this theory, how covalent bond is formed means first covalent bond. How covalent bond is formed means sharing of one electron pair between the two atoms. How covalent bond is formed means sharing of one electron pair, sharing of one electron pair, sharing of one electron pair between the two atoms. Sharing of electron pair between the two atoms. So first donating each atom one electron, then sharing takes place. Due to that sharing, the chemical bond is formed, that is a covalent bond. It is X. Example, X, it having a electron, plus Y, it having a electron, then X and Y mutual sharing of electrons, a bond is formed. This is nothing but a covalent bond. So this is a sharing. So then covalent bond is formed. It is a atom. It is a one more atom. Then sharing. It is nothing but a covalent bond. Okay. Types of covalent bonds. 3 types. Types of covalent bonds. Types of covalent bonds. How many types? 3 types. The first one is single covalent bond. Single covalent bond. Okay. So how the single covalent bond is formed means due to sharing of one electron pair between the two atoms. Due to sharing of one electron pair between two atoms. Is called single covalent bond. For example, chlorine. So it having 7 electrons in its valency shell. 7 electrons in valency shell. So I am representing 7 electrons. Chlorine having 1, 2, and 1. One more chlorine I am taking. Which having 7 electrons. Okay, like this. Now sharing takes place. So here due to sharing, it having 8 electrons. Due to sharing, it having 8 electrons. Okay, so it is a stable, it is a stable. Now it can be represented as Cl single bond, Cl 1 2 1 2 and 1 2. So it is 1 2, so 1 2 and it is a 1 2. So this is Lewis dot structure for Cl2 molecule. Here one bond is formed, that is a sigma bond. That is a sigma bond, it is a single covalent bond. Then a double covalent bond. A double covalent bond. Okay, due to sharing of 2 electron pairs, due to sharing of 2 electron pairs, 2 electron pairs between the 2 atoms, between the 2 atoms, due to sharing of 2 electron pairs, 2 electron pairs between the 2 atoms. So for example, 2 electron pairs, so 1 electron pair. For example, oxygen. Okay, it having 6 electrons in Vs, means valency shell. Okay, and then oxygen, how many electrons? 6. 1 2, so 1 2, so 1 and 2. Okay, one more oxygen I am taking. How many electrons it having? 1 2, so 1 2 and 1 2. Now sharing 2 electron pairs. So now these 8 electrons belongs to this oxygen, and now these 8 electrons belongs to this oxygen. Okay, it may be represented as oxygen, a double bond oxygen, and here 1 2 1 2. Okay, it is a 1 2 and it is a 1 2. So these are unshared electrons, these are unshared electrons, so these are shared electrons. If 2 double bond is formed, means one is a sigma, another one is a pi. One is a sigma, another one is a pi. Then triple covalent bond we are going to discuss. A triple covalent bond. It is not a James Bond, it is a chemical bond. Okay, so triple covalent bond. So due to sharing of 3 electron pair between the 2 atoms, due to sharing of 2 electron pairs between the 2 atoms, between the 2 atoms. Okay, so example nitrogen. Okay, how many electrons? 5 electrons in valency shell. Then, so nitrogen having 5 electrons, 1, 2, so 1, so 2 and 3, 5, and then one more nitrogen I am taking here, which having 5 electrons, and 1, 2. Now sharing, okay, sharing. So 3 bonds are formed. Now these 8 electrons belongs to this nitrogen which is stable. Now this 8 electron belongs to this nitrogen which is stable. Okay, this is a Lewis dot structure. We may represent N triple bond, N having low unshared electrons, Here it is a sigma bond, it is a pi bond, So this is the way covalent bond can be explained. So this is a single bond means sigma bond. So what I mean to say, by sharing of one electron pair between the two atoms, mutual, first donating, then sharing, then sharing of one electron pair between the two atoms, covalent bond is formed. This is briefly about a covalent bond. Okay. Then Lewis dot structure of Lewis dot structure of S minus 2. Okay. See here, sulfur atomic number is a 16. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p4. 16 means 10 plus 6, 16. Here it can be denoted by, it is a valency shell. It is a Vs, valency shell. Means how many? 6 electrons. 1, 2, 3, 4, 5, 6, like that we may donate. Now gaining 2 electrons from outside. Now S minus 2 is how many electrons? 18 electrons. Then 1s2, 2s2, 2p6, 3s2, 3p6. It is a valency shell. Now S 1, 2, 3, 4, 5, 6, 7, 8, gaining 2 electrons. So this is Lewis dot structure of S minus 2. Understand? Then in the same way we may give Lewis dot structure for any molecule. So next we are going to discuss formal charge. So here, what is a formal charge? It is important. Formal charge. What is a formal charge means? The difference between the actual electrons and gaining or loss electrons. Difference between the actual electrons and gaining or loss electrons is called formal charge. So we have a formula, formal charge. Formal charge means we may donate Fc. Okay. Now we have a formula for formal charge. Formal charge is equal to number of valency electrons in the free atom, number of valency electrons in the free atom, number of valency electrons in the free atom, okay, minus number of valency electrons in the free atom minus number of unshared electrons, number of unshared electrons in the free atom, number of unshared electrons in the free atom minus number of bonds around the free atom, number of bonds around the free atom. Okay, it is the formula for Fc. Fc means formal charge. For example, ozone. Then it having 6 electrons in the valency shell. 6 electrons in valency shell. I am representing. Okay, oxygen and oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, like this I am representing. Okay. So bonding, next bonding. Oxygen and oxygen. Single bond 1, 2, 3, 4, 5, 6. 1, 2, here double bond 1, 2, 3, 4. See here, unequal sharing. Due to unequal sharing, some atoms gets a positive charge and some atoms gets a negative charge. So which atom gets positive charge and which atom gets negative charge, we are going to discuss. It is a first one, it is a second one, it is a third one. Now we are going to discuss formal charge of oxygen 1. Okay, so this one is equal to valence electrons how many? 6. 6 valence electrons minus unshared electrons how many? 2 minus bonds how many? 3. 6 minus 5 means plus 1. So its formal charge is a plus 1, means it loses 1 electron extra. Then Fc of oxygen 2, Fc of oxygen 2, this is equal to, okay. So what is how many electrons? Valence shell 6, all oxygens containing 6, minus number of unshared electrons, this one, how many? 6, minus 6, minus how many bonds? 1, so it is a minus 1, its formal charge is a minus 1. Then Fc of oxygen 3 means this one, how many valence electrons? 6, minus unshared electrons how many? 4, minus 4, bonds how many? 2, so this is equal to 0, its formal charge is 0, means it loses 1 electron, it gains 1 electron, it neither lose nor gain, it is nothing but a formal charge, important for Sept. Sept, it is for IP, it is for IP, it is for Sept, okay. This is formal charge, it is a Lewis dot structure, Lewis dot structure. Next we are going to discuss bond order, next resonance, see, you have to know bond order. Bond order. What is bond order means? The number of bonds present between the two atoms. The number of bonds present between two atoms is called bond order. See, for example, hydrogen single bond hydrogen, so bond order equal to 1, okay. So bond order equal to 1. Next O2, oxygen double bond oxygen, so therefore bond order equal to 2, okay. Then nitrogen N triple bond N, therefore bond order equal to 3. So here 1 bond, so bond order is 1, here 2 bonds, bond order is 2, here 3 bonds, bond order is 3. The number of bonds present between the two atoms is nothing but a bond order, okay. And then resonance structures we are going to discuss. Resonance structures we are going to discuss. Resonance structures. So what are resonance structures means? See, one molecule cannot represent with one structure. So one molecule can be represented by more than one structure. They are nothing but its canonical structures. See, without changing position of the atoms, without changing number of electrons, without changing number of bonds in that molecule, we may give for one molecule more than one structure. They are nothing but canonical structures. This canonical structure represents a parent molecule structure, is called resonance structure. Okay. For example, O3, ozone molecule. So it having 6 electrons in 6 electrons in valency shell. Vs means valency shell. Then here ozone 1 2 3 4 5 6, 1 2 3 4 5 6, 1 2 3 4 5 6. This is the way I am representing. Okay. Now between these two, one single bond is formed. Now between these two, one double bond is formed. Now I am not going to change position of the atoms and not going to change number of bonds. I am not going to change electrons also. Giving one more structure. It is the first one. Next, oxygen and oxygen. Double bond, single bond. How many? One pair. 1 2 3 pair. Here 1 2 3 4 5 6. Okay. It is nothing but a second structure for this molecule. These two are called canonical structures. These two are called canonical structures, which represents parent molecule. So by observing these two, I am giving one more structure. So it is oxygen and oxygen. Here single bond, here single bond. So double bond I am implementing like this dotted lines. So here it having how many? 1 2 1 2, and this is the way we may represent its canonical structure. It is 3. It is the original structure of these two. It is nothing but a resonance structure. Resonance structure. Resonance structure, which is more stable. 1 2 are canonical structure. The third is nothing but a resonance structure, which represents 1 2. So this is nothing but a resonance structures. So what I mean to say, resonance structures means one molecule does not represent by one structure. So one molecule can be represented by more than one structure, without changing number of electrons in their valency shell, without changing number of bonds surround the atoms, without changing position of the atoms in the molecule. So these two are called canonical structures, which represents resonance hybrid. It is nothing but a resonance structure. Okay. So due to resonance structures, energy decreases, stability increases. Energy decreases, then stability increases. So this is the way we may discussed. Okay. Then now here what we discussed in this class means, so this is for IP. This is for IP. Then it is for MSET and it is for IP and MSET. So what we discussed in this class means Lewis-Langmuir theory, which explains covalent bond and types of covalent bonds. Types of covalent bonds means how many types we have? Types of covalent bonds 3 types: single, double, triple. Next, bond order. Next, formal charge. Formal charge means like this. You may practice some more molecules formal charge. Next, bond order. The number of bonds present between the two atoms is called a bond order. Next, resonance structures. Resonance structures means the molecule, one molecule having more than one structure, which are nothing but canonical structure. Canonical structure represents the original parent molecule structure, which is a resonance structure. Okay, so this is the way. Okay, stand means understand. This is the way you have to practice some more examples. So chemistry is, it is very easy when you are working continuously. So then stay safe and keep working, living.